So what are we worried about with fractions? What's the thing we can't do with fractions? We can't divide by 0. So what is x not allowed to equal there? Okay, think on what value makes the bottom 0? A -7. Because -7 plus 7 would be 0, and I don't want that. Number 2, what is x not allowed to equal? Okay, it's not allowed to be 0 because then the bottom is 0. Number 3, there's something I maybe should do to this first before I decide that. So here I want to factor. Okay, so I know that there's only one possible way to do that. 2x and x. You could flow this all out, do it the long way, or there's 2 things you would try. How do you get the 4? 2 times 2 or 1 times 4? Can you think of a way to get 7? Would you use a 2 and a 2? Or would you go with a 1, 4? You would go with a 1 and a 4. Can you see my swivels? They make 8 and 1. Okay, so I broke down all the FOIL pieces in my head when I did that. So 2x squared, 8x, 1x, I want positive, negative to make the 7. And then the last is a -4. And again, if that was weird for you, too much, just flow it, get your pairs, do all that stuff. Okay, so now x cannot equal. There's 2 numbers that I don't want it to equal. Okay, so this one is going to be a fraction. Do you remember how to do that? Opposite, divide. And this bracket is a -4. Okay, multiplying, dividing, reducing, all that. Okay, x minus 1 stays. There's nothing I can do. Can you factor the bottom, please? It's a simple trinomial, right? So factor out the bottom. Okay, so x, a 5 and a 1. You need a +4 on it. Okay, next, this, I need a difference of squares, factoring, right? Do you see that style? Difference of squares. So you should be working with a ±5. And this one gets factored as well. What's that style? GCF. I could take an x out, which leaves me with an x and a -5. Okay, so now everything is connected, multiplying, dividing, so I can cancel a top and a bottom. So x minus 1, x minus 5, x plus 5. All I have left out of all this is an x right there, but how do I write my final? Did you make sure you put 1 on the top? Okay. The x is on the bottom, so don't just write x. That's different than 1 over x. Okay, number 2. So again, you can flow this. It's a complex. You can flow it, partners, do a whole process. I'm going to do it with guessing and checking because there's not many options here. I'm going to start with the L. There's only one way to get the L. What does your L have to be? A 1 times a 1. So now this is where I guess and check or strategize. What should I put here? So what do you think? Do you want to go with a 1x, 4x? Or do you want to go with a 2x, 2x? Those are your two options. Do you see a way that you could also make 4x in the middle? Do you see it? So if you did 2x times 2x, that's 4x squared. 2x, 2x, that's how you get your 4x, right? Okay? Okay, on the bottom, we have a simple. So x, can you multiply something to 12? That adds to 1. 4 times 3? Plus 1, so I need plus 4. Okay, what do I do with this whole piece right here? Dividing by fraction. What do you do? Times and flip it, right? So 2x plus 1 is going to be on the bottom. There's nothing I can do with it, so I've written it already. But there's something I can do with this one yet. Which style is this one? I don't like negative x, right? I don't like negative x. So negative 1. So that would turn my x into a positive x. And it would turn the 3 into a negative 3. Okay, so I'm going to cancel x minus 3. I'm going to cancel 2x plus 1. Okay, last one. What could I divide those two numbers by? Four, right? Or negative 4? I'm going to say negative 4. So if I divide this by negative 4, it's going to cross out and become negative 4. If I divide this by negative 4, it becomes 1. How many x's could you possibly divide out? 1x, right? So this x would cancel to 1. And x to the 6 would become x to the 5th. y7, I can cancel a y out. So if I do that, this is canceled, and then this is y to the 6th. Okay, so the final is negative 4x fifth over y to the 6th. Okay, adding, subtracting. So I'm going to factor everything. So can you give me some factors? They're all simple trinomials there. So factor that out yourself. Okay, so did we get x plus 5, x minus 3? And then the other one, x plus 6, x minus 3. That's good? Okay, so now I'm going to go into a mode where I think, what do I all need in my denominator? Because adding, I have to put them on the same bottom. Okay, so I need an x plus 5. I need an x minus 3. And I need an x plus 6. Okay? This fits in, this fits in. I don't need to repeat that one on this one. Okay, now I'm going to look at the first fraction. What did I do to the bottom? This bottom I multiplied by an x plus 6. So I do that to the top, which foils or distributes, so I should say, to 6x squared plus 36x. Okay, second fraction had that and that. So it was missing, or what did I do to it? I multiplied it by an x plus 5. Okay, here's where I catch a lot of errors on the test. Be careful, what are you doing? -8 is going through there, right? So be careful with your signs here. So I'm subtracting an 8x and subtracting 40. So that's usually the spot that people lose a half point on, right there. Okay, that negative. Where did I get a -3?
No, why don't you do the -3 and 8? X -3.
Like you wanted me to do that?
Like,
Right here?
Do we choose one or?
Well, look at this bottom, and then look at this bottom. Okay, what is different about this bottom?
Oh, it doesn't have.
It doesn't have an x plus 5, so that's what you did to it. So now you got to do that to the top. Yeah. Okay, so I'm going to collect stuff if I can. So 6x squared, what is that, 28? X minus 40. Okay, next one. Factor the bottom. What do you want to do to this one first? What should you do? Which style first? There's actually going to be two. What would you do to it right away? GCF? Okay, so take an M out. Now, you have simple yet? Okay, so get me 3 multipliers on that one. Okay, next, that bottom is a difference of squares, so do that out. Okay, let's talk about what we all need in here. So we need an M. We need an M minus 1. We need an M minus 2. Then I would also need an M plus 2. Okay, this fraction to this fraction. What did you do to this bottom? What was missing? The M plus 2? From here to here, you multiplied by an m plus 2. So I multiply the top by m plus 2. Creating 4m plus 8. Okay, this bottom to this bottom, what did you do? There was an m and an m minus 1. Okay, now here's the situation. This is something times something times something. There's 3 things. Multiply 2 of them. And then after the third. So I'm going to do this. I'm going to multiply those 2 together. So forget the 7 for a second. I'm just multiplying those 2 together, making m squared minus 1m. M squared minus m. Okay? Now, I'm going to multiply by the third thing. Okay? So that's, you're going to run into it in one spot on your test. At least, so make sure you do 2 things together, finish that, then the third thing. So plus 7m squared minus 7m. So on your final answer, you keep the bottom. Simplify what you can on the top, if anything collects. So 7m squared minus 3m. Okay, complex. Okay, I'm just going to write this as an over 1 and this as an over 1. Okay, there's a 5. Here's a 1. What's the bottom that's common? I'm going to need a 5. Okay, so if I have a bottom of 5, x, what happens to it? Nothing. Here the bottom was 1. So what do I have to do? I have to multiply by 5. So plus 10. Okay, 20 on the bottom, 1 on the bottom. So what am I going to need? I'm going to need 20. So what am I doing to this? Nothing. X squared. What did I do to this bottom? 20. So 20 makes minus 100. Okay, at this point I'm going to change this question to the divide fraction. It's becoming multiply flip. So there's my multiply flip. Okay, fraction divided by fraction becomes fraction times flip. Okay, we can work with this. What can we do to this? It can change to an x plus 10 times x minus 10. Now everything is connected with multiplying because it's this times this divided by this times this times this. We've connected the whole piece with multiplying, so we can cancel stuff. Okay, so x plus 10, x plus 10. And 20 and 5. I can divide them both by 5. So that becomes 4 and 1. There's your final answer. Okay? Please also remember something like this doesn't reduce, right? Because those are adders. You can't do any reduction in that situation. Okay, solving equations. So I've proposed 2 strategies for you. Cross multiply or common denominator. So what's this strategy? Should we pick cross multiply? Okay, so this times this equals that times that. Okay, so x squared plus 11x, good, equals 6x squared minus 9x. Okay, algebra branch time. What do you want to do? One variable, isolate, or 2 variables, which method? We have 2 types of variables. We have x squareds and x's. So I need to zero one side. Okay, so who's the boss in this situation? 6x squared is the largest thing that I'm moving everything to it. So I'm going to subtract x squared and I'm going to subtract 11x. Because remember, the whole point is zero one side. So 5x squared minus 20x. Okay, so go through your factoring styles. Do any of them work? Do you have one of the styles that will work? GCF? So I'm going to bring 5x out. Leaving me with x minus 4. So the solution is x could equal what? X could equal what? Did you pick 0? And 4? Okay, let's double check that they're allowed. What is the not permitted value here? What am I not allowed to have? 3 over 2 is not allowed. What else is not allowed? Negative 11. So these are good. Okay, you have to check. If one of these solutions was the value you weren't allowed to have, you would have to cross it off, right? Okay, next one. Cross multiply or common denominator? Common denominator. So I'm just going to put that over 1 right now. And I'm going to factor this. So it's a GCF x. Okay, so here's my setup. So what do I all want to put in there? An x and an x plus 1. Okay, and each side has to be the same. Every denominator you see would have to fit in there. Okay, so the first fraction, you used to have a 1. So therefore you multiplied it by an x and an x plus 1. Okay, so multiply 2 of these things together first. So I'm going to pick these two because that multiplies to x squared plus x, right? Because I already knew that on the bottom there, right? Then I still have to multiply it by 2 yet. So 2x squared plus 2x. Next fraction, that was the bottom, so I did nothing. So the bottom, or the top, is just subtract 1. Do nothing to it. Okay, and on this side, x plus 1, I'm going to have to multiply by an x. So 3x. Okay, please make sure you are following where your equal sign is. Does that make sense? Make sure everything on the equal sign is on the right or left side where it needs to be. Okay, so my conclusion is if the bottoms are the same, I better make sure just the tops are the same. So 2x squared plus 2x minus 1 equals 3x. Bless you. Okay. Algebra branch. 1 variable, 2 variables. Okay, so it's 2 variables. So I need a 0 on one side. Okay, so this would be a complex trinomial factoring. So if you want, you can try to FLA it, or if you're getting better at breaking the foiling process down, you can understand that that's the only option there. That's the only way to get 2x squared. And the only way to get 1 is a 1 and a 1. Can you do the out and in to a negative 1? Will it work? So x equals negative a half or positive 1. So I'm going to go back. I'm going to double check just to make sure I didn't have a solution that was not supposed to be there. Okay, what are we not allowed to have? I'm not allowed to be a 0 or a negative 1. So we're good. Okay, word problems. A solution, 10-liter antifreeze and water, is already 30% strong, and we want to dump more in to make it 50%. So how much should we dump in? So right now, I start with 10 liters of mix. If it's already 30% strong, how much chemical is in there? 30% of that mixture is already chemical. So what is that? So we times it by 0.3 makes 3 liters of chemical in there. So there's 3 liters of antifreeze, and then we're gonna dump more antifreeze in there yet. Trying to increase the strength. Okay, so the top, we need to say what's the chemical portion. So we actually started with 3, and then we added more. Sometimes you just start with water, right? So if you just start with water, then there's just nothing plus A, right? But here we'd already started with some in it. Fluid on the bottom. What's the fluid situation? The whole fluid started at 10, but as you add any kind of fluid, that 10 in the jug is also going to be going up as well, right? And our end goal is to be 50%. So we can instantly write that over 100. Okay, that's our setup. Now we decide our strategy. So cross multiply or common denominator. So we should pick cross multiply. So 300 plus 100A. The other side, 500 plus 50A. And some of you would have maybe done this at the start. You could have done a 1 and a 2 here, right? That would have been fine. Okay, so I need to, one variable branch, the algebra, I'm going to isolate. So collect my A's together. So minus 50A. I'm going to minus 300. And divide. Okay, so you should add 4 liters of antifreeze in there. Okay, it takes John 45 minutes to push mow the yard, I'm already going to set this up here, time and rate with a John and a Jacob. Maybe I shouldn't have used 2 J names here, but okay. It takes John 45 minutes to push mow the yard. So is that the time they've worked or his rate? Rate. If Jacob helps, then it takes them 25 minutes. So that's the time. If Jacob were to work alone, how long would it take him? Okay, so figure out time, rate. Now, when we set up our proportion of the job, John does 25 out of 45 parts of the job, plus Jacob does 25 somethings of the job, right? It's always a time divided by rate, and the portion that he does plus the portion that he does finishes the whole job. Okay, so this fraction is representing the portion of the job that they did. Cross multiply, common denominator drop. You're picking your method now. So common denominator is the method. So I'm picking 45x to be the bottom. Okay, so what's going on? This fraction would have got multiplied by x. This fraction would have got multiplied by 45. So 25x plus 1,125. Okay, and then when I just think 1, I just make sure it's the top, bottom the same, right? Okay, now forget the bottom. The tops will need to be the same. So 25x. So there's my statement. Okay, so I'm going to minus 25x from both sides. So that will be 20x. Keep going with your algebra, see if you can get an answer here. Okay, word problems. So what does it mean? What are you figuring out? What is x? X is how long Jacob takes if he is working all by himself. All right, 2 more and then we're done. Okay, we're filling up a pool with 3 hoses. So I'm going to do a time rate situation again. If you were to just use hose number 1, it would take 20 hours. So that's the rate. If you just use hose 2, that's 15 hours. That's its rate. If you just use hose 3, it's 25 hours. That's our rate. So how long would it take if they're all working together? That's the time. And it's going to be the same time because it's the time of them working together, which is once they're done, the time is up, so it's the same. Okay, so each portion, so number 1 does x 20ths, number 2 does x 15ths, x 25ths, and each portion adds up to the whole job. Same as last time, we're going to think common denominator both sides. Okay, I already see lots of calculator typing. Someone's going to get me a number here. What's a number that works? Is 300? Is that the first one you found, or what? Anybody find anything lower? Okay, so 300. Okay, so how did I turn 20 to 300 there? I timesed it by 15. How did I turn 15 to 300? I timesed it by 20. How did I turn 25 into 300? I timesed it by 12. So the tops are now 15x plus 20x plus 12x. How do you write something that looks like a 1? Same over same. 47x is that whole top. What are we getting here for time? I'm going to go 2 decimals here. Does my answer make sense? All the hoses, when I get them all going, now the job's 6.38 hours. Okay. A boat travels 18 miles upstream in the same time the boat travels 20 miles downstream. So I'm going to go like this. The time up equals the time down. And what do I know about the formula for time? Does anybody remember it? Distance over velocity, right? So I'm going to set myself up with some fractions. Okay, the boat travels 18 miles upstream. So that's there. In the same time, the boat travels 20 down. The current of the water is 2 miles per hour. Determine the speed of the boat. Okay, so this is the boat, this is 2, this is the boat, this is 2. I have to decide if I'm going to add or subtract. So on these questions, by the way, sometimes I might give you the boat speed and you find the water speed, or sometimes I might give you the water speed and you find the boat speed. Okay, you can go both ways, right? Sometimes you might have, let's say, 40 plus x, or whatever, right? Okay, up, going up, what do you want to do with this number? Add or subtract upstream? Subtract. When you're going up the stream, it's slowing you down. When you go downstream, it's speeding you up. So I'm picking a method here. Cross multiply, common denominator drop, cross. Okay, so 30 or 18b plus 36 equals 20b minus 40. That's the cross. Algebra branch, we say we have one variable, so we're isolating. So collect b's. So I'm going to subtract 18b. Okay, I got all the b's together. So now I'm going to add 40. So don't forget what your answer is representing: the speed of the boat.